Okay. How many of you have ever looked at the night sky and wondered if there are other lives up there somewhere? Probably most of us. There are between 100 and 400 billion stars just in our galaxy, in the Milky Way galaxy, with most of them having a couple of planets orbiting them. However, we are going to step out of our solar system and take a journey to above and beyond. We will exit our solar system and we will even exit our galaxy, the Milky Way, and go all the way to see the observable universe at one glance. Now, at this scale, every single dot that you see is a galaxy, not a star, a galaxy, each containing billions, hundreds of billions of stars. The estimate is that we have about 2 trillion galaxies in the observable universe. Now, if we take 2 trillion galaxies and multiply that by, let's say, 100 billion stars, which is the lower estimate, and let's see if each star has only one planet orbiting it, that brings us to a mind-boggling 200 sextillion stars and planets. Now, I know the human brain is not capable to comprehend such a number. It cannot even understand what that means, right? But as you walk on the beach, you will see grains of sand. We all played with it as we were little kids, built castles, sand castles, and stuff like that. Now, there are 100,000 times more stars in galaxy than there are grains of sand on all beaches on Earth. The question you might ask yourself is, are we alone? Well, the Italian physicist Enrico Fermi raised this question in 1950, that with so many planets in the universe, shouldn't it harbor life? Of course, he meant intelligent life. If yes, where are they? We should have been visited by them over and over again, but all observations lean towards the fact that we are alone. This observation became known as the Fermi Paradox, and ever since, people try to solve it. Are there other civilizations somewhere that we might encounter someday? Well, first, let's see how life evolved on Earth and what we mean with civilization on cosmic level. About 5 billion years ago, our sun, just like every other star, was formed from a cloud of dust called nebula. There was enough unused material outside the center that formed other planets, including Earth. However, our planet was formed at exactly the right distance, not too far to become a frozen deadland, and not too close to become a burning torch, but exactly in the Goldilocks zone or the habitable zone. But that was the beginning of the journey. Earth has been equipped with a strong magnetic field to protect itself from solar winds. Solar winds are highly energized particles that can destroy every form of life. They can penetrate living cells and alter DNAs, causing mutation and cancer. And when I say mutation, trust me, it's not going to turn you into X-Men. So it will be something bad you don't want to experience. So without that magnetic field, we would be highly vulnerable if that protection was not there. Then we have a good water-rich planet. About 70% of our planet is covered in water, which is essential to life as far as we know. And all life on Earth depends on this magical substance. Next, we have a thick atmosphere. We should be very grateful for this atmosphere that we have above our head. The atmosphere protects us from UV radiation, warming the surface through heat retention, and its pressure keeps water in liquid form. Yes, water cannot exist in liquid form if there is no atmosphere. It will freeze, no matter how hot or how cold it will freeze. Last but not least, we have and still have celestial help. If it wasn't because of the huge planet Jupiter, which acts as a gigantic shield against comets and asteroids, life either may not have formed or it might have been wiped out over and over. And Earth may have turned into a wasteland. Also, we were lucky to have a Mars-sized planet crashed into the baby Earth, which our oversized moon was created from. The moon slowed down the rotation of Earth from few hours a day to 24 hours a day, giving life more time to use the energy of the sun. It also stopped Earth from wobbling around, enabling predictable seasons. It caused tides, which helped life to migrate from water to land, creating various kinds of species. Yes, the moon is really extremely essential to life on Earth. Change or alter any of these situations in the past, and we would not be here. But the miracle doesn't end here. These conditions allowed carbon atoms to bond with other elements, making complex chemical interactions, resulting in more complex molecules we call the building blocks of life, or carbon-based molecules. And to a still unknown process, these molecules were able to replicate themselves to a protocell. Over millions of years of evolution and natural selection, these cells resulted in more complex life forms. It's the same process that took billions of years to result in highly sophisticated life form we see today. So we are very fortunate to live on a planet where odds were in our favor and where life flourished. But what do we mean with civilization? How do we define civilization on a cosmic level? Well, back in the 60s, a Russian astronomer, Nikolai Kardashev, created a method of measuring a civilization level of technological advancement based on the amount of energy that they can harness. The scale has three designated categories. Global civilizations can be categorized in what's known as the Kardashev scales. And it goes from type 1, type 2 to type 3. Now, type 1 civilization or planetary civilization, they can use all energy available for them on their planet. Well, you probably think that we could be a type 1 civilization since we use all forms of energy on Earth, but we are actually 0.7 since there are a huge amount of energies we cannot store or even use. Just imagine the insane amount of energy of earthquakes or tsunamis, volcano eruptions, thunders, tornadoes, and hurricanes. If we could control it, we would be able to control our climate and planet's temperature. Only then we could claim that we reached a level type 1 civilizations. We reached the level of a type 1 civilization. We move forward to level 2 civilizations, which is also called a stellar civilization. These civilizations, they can use and store their energy on their planetary system. An example of that would be a so-called Dyson sphere, a hypothetical megastructure that completely encompasses a star and captures a large percentage of its power output. We could use this energy not just on Earth, but throughout the entire solar system. We could terraform Mars or even farther out planets and make it habitable and ready to be colonized. Am I going too fast? Please let me know.
No, it's perfect, Sam.
All right. I was just wondering, maybe I'm going too fast. Okay, then we move to last but not least. This is the type 3 civilization, also called a galactic civilization, that they can control and use all forms of energy with their entire host galaxy. Well, it's kind of hard to come up with an example of a type 3 civilization, but the closest I could think of are probably these guys. Since they operate on a galactic level, I would call them the closest to a type 3 civilization. Otherwise, I don't know anything closer than that. However, considering the vast distances of cosmos, even the closest galaxy to ours is so far away that the chances that we ever encounter intelligent life, even if existed, is almost zero. The closest major galaxy to us is Andromeda, which is 2.5 million light years. It means if we travel, if just hypothetically, we could travel with the speed of light, it would take us 2.5 million years to get there. So there is, and all other galaxies are actually farther away. So it's better to stick to our own galaxy and see if there are or there could be civilization within our galaxy. Exoplanet data reveals that most planets orbit a host star. If true, then there are trillions of planets just in our galaxy. So it's very unlikely that we are the only planet that harbors life. Now, probably the most famous attempt to solve the Fermi paradox was the Drake equation. Now, before you say, oh my God, equation, I don't know maths. Okay, first of all, if you passed middle school, you should be okay. However, I promise I will be gentle, okay? It won't hurt, and I will explain everything extremely easy. Now, back in 1961, astronomer called Frank Drake hosted a SETI meeting and introduced his famous equation. SETI stands for Search for Extraterrestrial Intelligence. This equation looks like this. It's not that hard. Let me explain. N, as you can see, this is the number of intelligent civilizations. That is what we are looking for. We are looking for how many civilizations are in our Milky Way galaxy. So this is our goal. N is our goal. The other parameters, so our star is the rate of star formation. How many stars are being born annually in our galaxy? F sub p is the fraction of those stars that have planets orbiting them. This will exclude lonely stars, stars that have no planets around them. We are not interested in them. So we are interested to find stars that have a couple of, which actually are most of stars, that have planets orbiting them. We move to N sub E, which is the average number of planets that might support life. Now, what that means is how many of these planets are in the Goldilocks zone. For example, for our solar system, there are 2 planets, Earth and Mars. Both planets are in the Goldilocks zone, in the habitable zone that could harbor life. Stephanie, let me know if I'm going too fast, okay? I might lose track, okay? Or no you problem. Can actually wave something. Hey, slow down, hold your horses.
No, it's great. Somebody just real quick asked if an ant colony counts as a civilization.
That's a good question. Maybe we should ask them. That was cool. Then we have F sub L. It's the fraction of the above planets where life evolves. So within our solar system, the example would be between Earth and Mars. Mars harbors no life, so it would be only Earth. So within those planets, those that actually harbors life or life actually evolves. Then we move to F sub I, which is fraction of the life that develops intelligent life. Now, let's be honest. If you know there is a planet that harbors life, but there you can find only bacteria or viruses, it's home of COVID-19, would you be interested to go there? Probably not. So we are interested to find if there are any intelligent civilizations somewhere in the galaxy. That's what we're looking for. Then we move to F sub C, which is the fraction of the above revealing their existence via signal release into space. What that means is the number of intelligent life that communicate over the electromagnetic spectrum, like radio waves or microwaves. So they can kind of communicate kind of wirelessly and release signals into space that we can just observe or get signal and we can respond back. Otherwise, there would be no way to communicate with them. And last but not least, we have L, which is the longevity of communication. Every single planet and civilization has an expiration date. Now, the longevity means how long they will be around. Our planet started 100 years ago. Before that, we could not communicate over the electromagnetic spectrum. We didn't have any radio waves or microwaves. So it started about 100 years ago. And we will not be around forever. Even hypothetically, just conceivably, if we don't kill ourselves, if we don't destroy our environment, if we don't get hit by a comet or asteroids, even if we just take all these into consideration, the Earth, by its nature, has a deadline. In 2 billion years, Earth will not be habitable. Okay, so there is a period where civilization can rise and reveal their existence, and they go extinct. Well, if they are very sophisticated, they make it to colonize other planet, good. Otherwise, it's gone. So that is L. So all we need right now is actually plug in these numbers to see what happens, right? As of right now, the star rate formation in our galaxy is 3. That means 3 stars every year. Every year, 3 stars are born in our galaxy, okay? Now, F sub P is about 100 billion, okay? That is the lower estimate of stars that have planets around them in the Milky Way. N sub E are so-called exoplanets that right now, today, we think 4,200 we already found, so we plug in 4,200. Now here comes the interesting part. I don't want to disappoint you, but the rest is actually question mark. We are not sure, okay? We don't have significant data for that. The rest is unknown. Put 0 for any of them and N will be 0. Of course, if we have no zeros, we will have a huge number. Now, we saw earlier that the chances that the Earth is the only place to harbor life is very unlikely. However, highly intelligent life is likely much more rare. We have seen no evidence so far that intelligent life might exist somewhere else. Now, you might argue that considering the vast distances, maybe we haven't discovered them yet, and you might be right. But so far, no data to back this theory up. I know you would be very disappointed if I just left you like that with giving you no numbers that you were waiting for the entire presentation. I don't want to disappoint you. Okay, I'm going to give you a little bit more. There's an approximate estimation of the number of intelligent civilizations that could theoretically exist in the Milky Way based on the distance of the discovered exoplanets that are in the Goldilocks zone and their age, the age of their star, how long they've been around, and some other parameters. It suggests that there are about 36 active civilizations in our galaxy. Now, let me ask you this. Do you think that's accurate? Probably not. Could it be more? Sure. Could it be less? Yes. Could it be zero? Absolutely. We are not sure. It's just an estimate. As the British scientist or science fiction writer Sir Arthur Clarke said, two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. Now, let me ask you something. What do you think? Do you think aliens exist or are we alone in the universe? Let your imagination go wild. And that's it. I end this and I stop sharing and I open the floor for questions. As I told you, I'm gonna wrap this up quickly so we have more time to go over questions and answers. Stephanie, do you have any questions for me?
Actually, the only other question was, have we found intelligent life on Earth?
Not that I know of.
So feel free to unmute yourselves if you'd like to ask. Either way, you can either put it in the chat or ask him directly. One other question that just popped up is, how has the Drake equation results varied over the decades? That's a good question.
It has not.
Oh.
Actually, it has not, because the problem with Drake equation is we don't have sufficient data. It's just an equation that we cannot totally plug in numbers. So it has not evolved. The exoplanets has changed. So in the past, we knew about by the time Frank Drake proposed this equation, we had about like 2,500 exoplanets discovered, and now we have 4,200. That has changed. But unfortunately, we need every single parameter because we are multiplying. And when you multiply, if one parameter is zero, it turns the entire equation into zero. So,
hi, Sam. Sam, it's Arlie. Hi,
hey, Arlie.
I have a friend who is convinced that extraterrestrial life has visited us, and his evidence is the crop circles. Any thoughts?
Okay, the crop circle is actually no proof, because they are some different pattern that they pop up every now and then. And what kind of strikes me all the time, that you know where the source of that beliefs come? It does not come from crops pattern. It comes from Hollywood. Trust me. The only reason we believe in aliens is Hollywood. There is no other reason. Now, you might see some fuzzy pictures, some fuzzy videos, hey, look, there's a UFO somewhere. Okay, let me ask you this. And there was recently, some of you might see, hey, there was a video released by Navy. I think that was last year or 2 years ago, that they see a very high speed, some flying object. So do aliens reveal themselves only to Navy? To no one else? And besides, let's say this Voyager that we sent out will be captured by aliens in 100 million years, okay? And they will see an UFO, something like UFO on their sky. Will the Voyager just disappear like that when they observe it, or will it be there? So it has no scientific value. We have no evidence. It's just the Hollywood that is obsessed with it. And some of us are as well.
How about the Nazca lines?
About what?
The lines in Peru, the NASCAR lines.
That's something similar that Arlie has mentioned, the crop patterns. Again, there is no evidence of how just because we don't know something, it doesn't mean aliens are involved, okay? So even if we don't know, even if we are not sure how they appeared, this is not a proof for alien life. There might be an explanation somewhere down the road, but there is no reason to believe aliens are involved.
Sam?
Now, let me tell you one more thing. Do you know how many telescopes are pointing towards the sky? There are more telescopes pointing at sky than we have cameras in casinos. Every inch of casino is watched with a camera. So, and we have like Google Earth, like satellites that watching Earth. So if they take off from place to a place on Earth, we would see it. There is no way that for so many years we couldn't capture even one of them. That is not very like feasible.
Yeah. Sam?
Oh.
Yes.
The Drake's equation, does that assume that we're looking for intelligent life just like we are constructed, or?
So far, we have not found any intelligent civilizations, whether they look like us or they look like others, or they are green man or with just antennas on their head. We don't know how they look like.
Right,
they might look like us or not. So
my point is they might not need an oxygen atmosphere. They might not be susceptible to heat or cold. I mean, if we're judging ourselves to be the reference point.
That's actually a very good point. We should not judge ourselves. Actually, we say, okay, we need oxygen, okay? There might be some lives that don't need oxygen to breathe. They just need methane, for example. So it is possible. And we are not judging, but however, what we agree on, some sort of like fluid, like water, should be there. So it's better just to look for something we know, like water, than something we don't know, some whatever substance to look for it. Good question.
Sam, one question says, are there any Voyager or Voyager-like probe vessels that are capable of detecting life on exoplanets in the Milky Way or outside the galaxy?
Okay, first of all, outside of galaxy, we can detect only stars, nothing else, okay? But we don't need, Voyager has stopped sending us pictures a few years ago because NASA wanted to preserve the energy of Voyager. So it just programmed it in a way that just a few years ago that stopped sending pictures. Voyager is not sending us pictures anymore, but it does send information in other way that, hey, right now Voyager reached the heliopause, which is kind of the area where the sun, like I said, the solar winds stops, but the gravity of sun is still there. So we cannot say it totally left our solar system. It's still there. It's still bound to sun's gravity. We can only say it left our solar system when it just out of the Oort cloud, which might take another 30, 35,000 years. Okay, but in order to detect exoplanets, we do not use Voyagers. We use our other telescopes that we have around Earth or orbits. They look for exoplanets to see what they find.
We even have a gear on the roof of RFO looking for not exoplanets, but extraterrestrial signals from space.
How many have we found yet? 3?
Zero, sorry.
Another question asks, have we identified any exoplanets out there which evolved with habitable conditions like
Good question. We identify exoplanets based on the distance from their host star. Like if a planet goes around a star, it blocks its light, and once it's on the backside, it just like reveals its light. So that just kind of goes dark and then back again. That this is something we can detect a planet. And based on other planets, the gravitational interaction, we can estimate the distance of that planet from the host star. And when we see, okay, now we know how big a star is, so what type of star that is, and then we can calculate the Goldilocks zone. And if that planet falls in the Goldilocks zone, it is an exoplanet that might harbor life.
Great. Let's see, there was also a question. Is there an estimate of the likelihood we have just not observed a radio signal from another civilization, assuming one exists in our galaxy?
I wish we would, but so far we have not found anything. Nothing. So far, unfortunately. But as David said, RFO is still watching actively, and when we find something, we will notify you. Right, David?
Eric asks, and Eric, you may have to pronounce this. What's your thoughts about Oumuamua? I don't know if I said that right.
We thought first Oumuamua was actually an intelligent object. Oumuamua is Hawaiian native name for visitor. Okay, extra.
Can you explain what the object?
I will.
Oh, okay. I'm sorry.
First, we saw an object is like approaching Earth. It was kind of elongated, something like Star Trek spaceship. We thought, hey, that is something that could be. So we started communicating on different wavelengths of radio waves. Hey, we are. Hello, ahoya, habalo, da. Nothing, no response. After communicating with various range of radio waves and received nothing, we realized that it is a natural object, unfortunately. It was a comet, but elongated comet. It was just weird shaped, so we thought it might be something exciting. It was not.
Well, Sam, I thought some of the discussion was around the strange acceleration patterns, the anomalous acceleration patterns that.
Yes, acceleration patterns can always be there when they enter a planet's orbit and then get kind of flung away. Like if something goes to like in the vicinity of a planet, and as it goes around the planet, it just get accelerated and flung away. Then we can see a difference in speed of that object. It doesn't necessarily mean that they hit the gas pedal to accelerate more. So yeah, it does not.
Thank you.
Oumuamua is anyway was a natural object. So you're on mute, Stephanie.
Sorry. Somebody would like to know how you got interested in this field.
Yeah, good. Okay, my background has nothing to do with astronomy. My major is engineering, computer engineering, nothing to do with astronomy. However, I was just interested, just like Rachel. I was interested, and it was my passion since I was a teenager. So I just read books, watched videos, studied myself. I never took any astronomy classes or courses. So everything I know, which is not much, of course, I just got it myself. So excuse me if my knowledge is not like as Rachel. So I hope you forgive me for that, Rachel.
I think, let me see. Just going through the questions. I think we have gone through the questions posted here.
While you're looking, Stephanie, I want to say, Sam, I thought you did a fantastic job of describing the Drake equation in layman's terms. I've known about it for a while, of course, but I thought you did a phenomenal job describing it. So thank you. Well done. Great presentation.
Usually when we talk about equation, people are scared and they say,
I get excited.
My God, equation. Wow.
I love it.
Drake equation is mostly based on wild guesses and speculations. It's not really based on solid ground.
I would agree with that, man, that you did a marvelous job with your presentation and explaining an equation in terms that people can actually understand is amazing.
Did you understand, Arlie?
Yes.
Oh.
I hadn't realized the level of uncertainty and lack of closure on the Drake equation until you presented that. So it was interesting for me to understand.
Yes, the Drake equation is not solid, but it's still the best way to solve the Fermi paradox. We still don't have a better approach to that than Drake equation. And all we're missing is just few more parameters. Once we have this, we can actually come to a conclusion. So when or who will discover that? I mean, I don't know. I don't know whether we will have it within my time lifespan or not, but hopefully, I don't know. Any other question? It doesn't have to be like Fermi related. If you have other questions, any astronomy questions, you can just go ahead and ask. It's totally fine.
Yeah, I think I addressed all the questions in the chat, but please speak up if I missed one, or yeah, feel free to unmute yourself and ask anything else.
Yeah, just don't be shy. Step in.
Here's your chance.
Yeah. Rachel, I'm expecting something from you.
Desperately racking my brain for a good question.
Oh, come on, Rachel. You can do better than that. We know that.
I'll come up with one. Give me a minute.
Rachel did have a comment that some people may have seen, but she said that Sarah Seeger, an exoplanet scientist, has created a modified Drake equation to address the fact that life might be very different from us, looking for biosignature gases, for example. And there she put a link to that too in the chat.
And sorry if I don't look the chats, because I'm sure Stephanie is addressing them, so I'm not going to that because I trust Stephanie. She looks everything.
Well, I have another question. So Arecibo, with the demise of Arecibo.
Sorry, what was that, Eric?
I have another question. With the demise of Arecibo, because I was heavily involved in SETI work, as I understand, is there a replacement program or structure or rebuilding planned?
Not that I know of. The major focus on NASA right now is the Spacer Webb Telescope. That they get this up as soon as it should be up there in 2019, and still it's not there. So that's what they're.
I just read about that there's a kind of grassroots organization on Puerto Rico that was involved with Arecibo that is putting together a proposal. There's no money, but they're putting together a proposal in hopes of getting money to put something else in there. So watch your techno news highlights in the coming months and years.
I just saw an estimate that they were saying it would take $60 million to replace it. And they'd have to do a environmental cleanup underneath the unit. There were a lot of cables and everything. Fortunately, I was able to see that a few years ago. It was quite amazing. They wouldn't let me in the control room, but they took me down to the disk, and I got a chance to look at that and talk to the people there.
Was Jodie Foster there?
Yes, as a matter of fact, she's the one that took me on the tour.
Molly asked, is the James Webb Telescope going up in October going to be able to observe exoplanets better?
It was supposed to go like 3 years ago. Oh. It's always got postponed over and over again. So whether it goes or not, who knows? Maybe, maybe not. It got postponed over and over again. I think John wanted to say something. John?
But I'm sorry. Part of her question was when it goes up, if it goes up, will it be able to observe exoplanets better than
no, because James Webb Telescope is kind of different. It will replace Hubble, and the plan is that they put it on L3 point, the L3 Lagrange point, which we have no satellite there so far. It's very hard to get it there, but this will hard to give you a demo. The Lagrange points are 5 points around the circle that once you put them on any of the points, they will just stay there forever on the orbit. Okay, it's called the Lagrange points. Now, L3 is exactly like if this is Earth and here is the sun, it's exactly on at this side. So it will not be blended by sun. So it will look deep in the space. and not get interfered by sun's radiation. That's the plan. It's very hard to get a satellite on L3 points, but that's the plan. Whether they can do it or not, I don't know. What was the next question?
John.
John.
In the, I think it was in the 1990s, I attended a lecture at San Francisco State with Jeff Marcy, and Frank Drake was there. I got to meet Dr. Drake. And in the Q&A session, I asked Dr. Drake what was the current solution to his equation. And at that time, he told me 10,000. I don't know, good, bad, yeah.
Well, the whole Drake equation is based on wild guesses.
Yes,
okay, there is no solid mathematical like plug-in numbers to get an exact. You can even this 36 that we know so far, or I shouldn't say we know, we guess so far, is based on the number of exoplanets that are within the Goldilocks zone of their host star and their their age and other parameters. That's how we got this number. But it's still, it could be way off. It could be zero. It could be anything in between. Yeah, we still don't know.
Well, wait, it can't be zero because we're here.
Well, other than Earth, of course. Or as Stephanie said, are we just a set civilization?
Yeah, someone argued that in the comments.
Yeah, we could argue that. Yeah, sure, we could argue that.
Gary asked, have there been any studies regarding the various factors that threaten our existence as a civilization in some sort of priority of threat?
Ourselves. Ourselves. We are literally killing ourselves.
Republicans.
I'm not going to make any comment on that statement. Yeah, but we are destroying our environment, that's for sure. And if that keeps going like that, there will be some consequences.
L will get very small for us in that formula.
Or was that?
L, that last factor, the length of communication, will get very small. Longevity will get small.
Well, it's just 100 years old so far. So let's see how long it will last. 1,000 years, 2,000 years. I mean, Earth will not stay there forever.
I think there's also, what is it, the B52 project or B12 project? I always forget the number, that's looking at the threats to all life on Earth and trying to... That's
only looking for comets and asteroids that are heading towards Earth.
Okay.
And by the way, even so far, we didn't have any problem, thanks to Jupiter. But even if Jupiter was not there and we got, it doesn't mean, as of right now, we have no solution. The solution that Hollywood showed you is not only a solution, that would be the worst thing we could do. Blow up a comet, that would be literally a disaster. We would be way better off if it hits Earth than blowing it up over there, because then we will hit with 1,000 comets. It's just instead of taking one bullet, you get 1,000 bullets. So that would be not, but for Hollywood, it works. Yeah. Yes, Stephanie, do we have any other questions?
I don't see any other, and a couple people posted a few links in the chat, but I don't see any other questions, but please, like I said, unmute yourself if anybody wants to come in.
I've got a question.
Oh, go Bob. Go Bob.
This is actually a comment. It's not a question. In the late 80s, a Jesuit priest appeared at the conference of the Society of Technology in Berkeley, which was a joint meeting between the theological seminaries in the area and the scientific community at Berkeley and so on. Anyway, this Jesuit priest, when asked why the Catholic Church, the Jesuits, instituted a new observatory in Arizona in the late 80s, after holding all the marbles in the eons ago, he said, and the fact that there are many institutions, educational and governmental institutions watching the skies, like you mentioned, Sam, this Jesuit priest says yes, you're right. There's a lot of people watching the sky, but we just don't want to be surprised.
This is not the first time that the Catholic Church does this. Do you know what year Catholic Church announced that we forgive Galileo?
That are you asking when that observatory was built?
No, not observatory. Church said we forgive Galileo Galilei for saying some, yeah. 1995.
He was
After
dead
spending
for a while.
billions of dollars to see whether he's right or not. So it doesn't surprise me.
Wow. Sam, I do have a question for you.
Sure.
So you've, I think, thought about this a lot. You know, is there life out there? Most likely. What can we find it? I have a question. If we got a signal from an alien life and we were like, oh, there's alien life, would that change anything you do or think or feel?
Is this a personal question?
Yeah, and I'm kind of posing it to everyone, but what I think about this a lot. What difference would it make for each of us? And I'm curious if you sort of have thought about this or have an answer.
I'll bet you'd have to update his presentation.
Thanks, Dave.
That's the number one thing I have to do, because the whole thing would be, hey, yes. So it doesn't, n is equal 1. So we found 1. Yeah, that's actually a very good question, Rachel. I'm not sure what I would feel. I think I would have 1,500 questions open to see where they're coming from, I mean, it just, I don't know. It's a big question. I don't know what to think,
yeah.
but
it's a fun question to think about. Like, I don't know the answer.
Or wait until it happens. It might not even happen in my lifetime. So, but yeah, everything is possible. Maybe. Yeah, but that was a fun question.
I think it would feel so wonderful. It would feel absolutely wonderful.
Well, it depends.
To find out that
like
there actually was other
once
life
said,
out there.
I don't know if people are reading.
When you are in the wild, you don't call out. So you don't know what type of civilization are waiting for you out there. Not better do that, but we did it. And we hope we get some response back. Now, this response might be good, might be bad, might be Hollywoodish, or no. No one knows. Everything that we think comes or kind of correlates with Hollywood movies.
Mm.
That's all what I can say, because there is no other scientific evidence on how they will look like. So, any other questions? Not that I can guarantee I can answer it.
James asks if there are any likely planets within a distance that we could send a message back to them that they would receive within a human lifetime.
That is a very good question. Unfortunately, I would say probably not. Messages are being sent through the electromagnetic spectrum, so is light, with the speed of light. If you consider like a planet is just 50 light years away, and if you send a signal, it takes 50 years until they receive it. If they respond right away, it will take another 50 years that we receive it. So it will take 100 years. So that would probably, and which is not important. We really don't care whether it's within the lifetime of a human. All we care, we get something. Just give me something, okay? We are starting communicating on the electromagnetic spectrum about 100 years ago. So ever since we send out signals, we haven't gotten anything back, but the space is really, really big. Like literally it might take thousands of years. But, yeah, but at least we get something, maybe.
Dave, Actually, a question for Dave. I know you mentioned the SETI laser SETI program at RFO. Do you want to, I don't know if how much you know about it, but can explain it really briefly, how it's, as I understand it, it's a little bit different than other SETI programs in that it is looking for, it's instead of auditory, it's a visible light kind of.
Yeah. So correct. The traditional SETI programs are looking for radio signals from the cosmos, from out there. And the equipment that we're hosting on our roof is run by the Laser SETI program. And it's an all sky, all the time program. They're watching for, since we communicate, we don't only communicate via radio waves, we also communicate using lasers. We can modulate lasers to get signals. And so the thought is, one more thought is that the light sails can be sent on probes, on beams of laser light. So they're looking for they're looking for laser signals coming from space. So while the rest of the SETI program is looking for radio waves, this is looking for light waves that are not of natural origin. And yeah, there's a whole cool technology behind how it works, but
it's all electromagnetic spectrum. Light has a long range of electromagnetic spectrum. It goes all the way from microwave to gamma ray. So this is the electromagnetic spectrum. And of course, radio waves is just part of it. Laser is the amplified version of light. So it's all light-based communication. Okay, so when we say light, we don't mean visible light, because visible light is really a very small portion of.
No, this laser SETI is actually looking for visible light.
Yeah, you mean the lasers that that built actually physically on telescopes, and they point out when you use the telescopes, they point out laser.
No. This is a receiver. It's a camera. That we have on the roof of the observatory. Yeah, we're hosting a site for this laser SETI organization.
Yeah,
and their program is looking for those signatures of communication over light waves, which yes is an extension of the electromagnetic, or part of the electromagnetic spectrum.
Yeah, it's part of it. It's a very small part of it. Like if you extend the entire electromagnetic spectrum from coast to coast, like from New York to LA, let's say that is the entire electromagnetic spectrum, that is the light spectrum. The visible light, anyone has an idea how long it would be, the distance? California, Texas, whatever. If this is the entire light spectrum, the visible light, which we can see, is about 2 inches. That is the visible light. The rest of it is invisible to human eye, but it doesn't mean it's not there, okay? It is there, we just can't see it. So that's the reason we have to build equipment to get those light, actually see that light. Yes, any other questions? We hit 1 hour, wow.
Rich just asked, is it arrogant of us to think that nothing can travel faster than light?
That is correct.
Is it possible a more advanced people know how to send a message faster?
No, it's not about how to send a message. It's about nothing travels faster than the speed of light. So that's the universal constant.
That we know.
The laws of physics always remain the same no matter what civilization uses it. It's always nothing can travel faster. Was that some other to the question, other part attached to the question?
No, I think no, I think that was all the questions, unless anybody, and we're at about 7.
Yeah, nothing can travel faster than light, okay?
Can you repeat what you just said? I didn't quite hear that.
Nothing can travel faster than the speed of light. It's the universal speed limit. Its speed limit, 65 miles. Its speed limit, light speed. That's the universal speed limit. Nothing can exceed faster than the speed of light.
Michael said, isn't space expanding faster than the speed of light?
Michael, you got me there.
The sticky wicket.
It was Michael. I don't see him, but okay. All right, Michael. Yes, you are right. The space, I mean, not that space, if you will look like really beyond Hubble range, Hubble horizon, the very far galaxies, they are just getting away from us faster than the speed of light, okay? Multiple times the speed of light in some cases. However, special relativity tells us that nothing in universe can travel faster than light. However, that does not mean the universe itself. It is not the galaxies itself that are traveling faster than the speed of light. It's the space in between that is ever expanding, and the space is expanding faster than the speed of light. So everything on that space is just going away, like just moving away from us faster than the speed of light. Just imagine you have some raisins in a dough and you put it in oven. As the dough expands, the distance between these raisins expands, but the raisins don't move. It's the space in between that is expanding. So the distance of raisins goes like this. It's not that. So yes, nothing can travel faster. Nothing in universe, nothing in space can travel faster than light, but it does not mean that space can travel faster. Space can travel with whatever speed it wants. Everything in between is bound to the speed of light. Was that clear? I'm not sure if I could explain it.
No, that was a good analogy. Somebody asked, is there a confirmed technique that ensures that FRB is from a exoplanet civilization?
I'm sorry, I did not get the question.
Oh, is there a confirmed technique that ensures a FRB?
Fast radio blast first.
Okay, is from a exoplanet civilization?
Not so far. We have not. Like, okay, we do not speak the same language, obviously, but however, once they communicate, we are looking for patterns. If we get a pattern that is emerging that cannot be caused by nature, because signals are coming for all natural sources. They can come from pulsars, from neutron stars, from magnetars, and so forth, so on. However, if we look at a pattern that does not talk to us like what we already observed, then we might have something maybe intelligent somewhere that, wow, so far we have not received it. So we look for pattern.
And actually, based on that, Keith asked, is it more likely that we would be the least developed forms of intelligent life in all the universe, or could we be the most developed based on math?
I don't know. I don't think that anyone knows.
Yeah.
I don't know. We might not. Who knows? We're not even sure if there is anywhere else like human, like intelligent life.
What?
So we have to first see there are intelligent life and then ask the question, hey, are there like us or others? So I don't know.
One thing to consider is that our solar system is second or third generation solar system, given the age of the universe. And so the universe is 13 point something billion years old. Our solar system is only 4 or 5 billion years old. So if it took us 4 or 5 billion years to go from a primordial dust cloud to an intelligent civilization, what about all the other years prior to our 13 or prior to the beginning of ours?
Well, you can't say that because that is only true if we consider that all civilizations, they all have to go exactly the same path that we did.
True.
Which might not.
But we only have one data point so far.
So it's not necessarily like that. They might be even smart. They might have developed like a better brain than us, developed faster. Everything is possible. That's only true if we consider that they all have to exactly follow our footprints.
There's another principle, and I can't remember the name of it, that says, don't assume that we are anything special. So You know, when you make
Actually,
make a mathematical assumption, when you do an assumption, assume that, you know, we are typical as opposed to atypical. So.
Well, this is more a philosophical question than a technical question. So I would say it's like it's a good amount of philosophy behind your question. So it's a lot to talk about it. So, yeah.
Well, doesn't that also include a given definition of what intelligent life really is?
That is a very good question, and we don't have an exact answer for that. However, as the Russian scientist, as I told you, Nikolai Kardashev, he presented a scale we can measure a level of civilization. But to define civilization, we have only one pattern, and that's us. So it's hard to imagine what other civilization would look like other than Hollywood. That is, there's not a definite answer to that, but we think like Kardashev's scale is something that we could rely on. So they are advanced enough to harness all the energy that are within their proximity. That's the closest we could get.
Thank you.
Well, I don't think there are any other questions. Yes, other than thank you so much, Sam. This was really, I learned a lot, and I'm sure everybody else did. It was very interesting. And thank you all for joining us. We are doing these speaker series every second Friday of the month. So the one next month will be about, I believe, about the Mars atmosphere. Description still to come, but definitely check out the link on rfo.org. We'll put it on our event calendar, or it probably already is, but we'll put a link to register for that. And thank you very much, and hope you all have a good rest of your evening.
All right.
Thanks, Sam. It was awesome.
Thanks, Sam.
Thank you, Rachel.
Bye.
Really thank you very much.
Thank you, Sam. Excellent. Great visuals.
Thank you, Anne. Thank you.
Really excellent.
Hope you enjoyed it.
Oh, really?
Thank you very much.
Great conversation. Thank you.
You're welcome.
Goodbye.
All right. All right. So all the RFO guys are here, right?
Yeah.
But I saw my daughter ran away real quick.
So now that we're under us, what do you think? What's your thoughts on this?
No, I should stop recording.